through. Have you ever scrolled through the internet and stumbled upon a heated debate about the shape of our planet? It's a question that seems simple, but has sparked incredible curiosity and controversy. Is the Earth flat? For thousands of years, humanity has looked to the skies and the horizon, trying to piece together the true shape of our world. Today, we're going to embark on a journey, not of opinion, but of observation and evidence. We'll explore the scientific proofs that have led us to understand our planet as a beautiful blue sphere. So, buckle up as we separate fact from fiction and discover the shape of our home, together. Let us start with something you can see for yourself, a ship sailing away from the shore. If the Earth were flat, as a ship sailed further away, it would simply get smaller and smaller until it vanished into a tiny dot. But that's not what happens, is it, Zed? We see the hull of the ship disappear first, followed by the mast, until the very top of the sail slips below the horizon. This phenomenon is a direct result of the Earth's curvature. The ship isn't just getting smaller, it's moving along a curved surface, gradually dipping below your line of sight. This simple observation, repeatable at any coastline in the world, is one of the oldest and most powerful pieces of evidence for a spherical Earth. Now, let's look up at the night sky. The stars have been our guides for millennia, and they too hold a secret about our planet's shape. If you live in the northern hemisphere, you're familiar with the North Star, Polaris. It appears to stay fixed in the sky, while other stars circle around it. However, if you travel south towards the equator, you'll notice Polaris getting lower and lower to the horizon. Once you cross the equator into the southern hemisphere, Polaris disappears completely, and new constellations, like the Southern Cross, become visible. On a flat Earth, everyone, regardless of their location, would see the same stars in the sky. The fact that your position on the globe determines which constellations you can see is undeniable proof that we live on a sphere. Different viewpoints reveal different parts of the celestial sphere above us. Have you ever wondered why we have time zones? Why is it daytime in New York when it's nighttime in Tokyo? This is another everyday phenomenon that a flat Earth model can't explain. If the Earth were a flat disk with the sun hovering above it, the entire surface would be illuminated at once. We'd all experience sunrise and sunset at the same time. But we know that's not true. Time zones exist because the Earth is a rotating sphere, As it spins on its axis, only one half of the planet can be illuminated by the sun at any given moment. This rotation creates the cycle of day and night, with the dawn terminator line continuously sweeping across the globe. The very existence of your morning coffee happening while someone else is eating a late dinner is a testament to our planet's round, rotating nature. Let's talk about gravity. It's the force that keeps our feet firmly on the ground, but its behavior also tells us a lot about the shape of our planet. Gravity pulls objects toward the center of mass. On a spherical planet, the center of mass is at the geometric center of the sphere. This means that no matter where you stand on Earth, be it in Canada, Argentina, or New Zealand, gravity pulls you straight down, towards the center. That's why down feels the same everywhere. Now, imagine a flat, disc-shaped Earth, if gravity worked the same way. Pulling towards the center of mass, the center of the disk would be the only place where gravity pulled straight down. As you move towards the edge, gravity would start pulling you sideways, back towards the center. Life at the edge would feel like you were constantly on a steep hill, which is clearly not the case for people living in Australia or Chile. The uniform downward pull of gravity we all experience is only possible on a sphere. One of the most beautiful proofs we have comes from a celestial event, a lunar eclipse. During a lunar eclipse, the Earth passes directly between the Sun and the Moon, casting its shadow on the lunar surface. Pay close attention to the shape of that shadow. Every single time, without fail, the shadow the Earth casts is a perfect circular arc, appease. As the eclipse progresses, this curved shadow sweeps across the Moon's face. Now, think about it. What is the only shape that always casts a circular shadow, regardless of its orientation? A sphere, a flat disk, could only cast a circular shadow if the light source was hitting it perfectly face-on. If it were tilted at all, it would cast an elliptical or a straight-line shadow. Defect: the fact that Earth's shadow on the Moon is always a circle, no matter the time of year or the position of the Earth in its orbit, is conclusive evidence that our planet is a globe. For the past 60 years, we've had a perspective that no previous generation could have dreamed of. We've seen our planet from space. Since the dawn of the space age, thousands of satellites, probes, and astronauts have sent back breathtaking images and live video feeds of Earth. These aren't computer-generated images. They are real photographs showing a vibrant blue marble suspended in the blackness of space. We've seen it from low Earth orbit, from the Moon during the Apollo missions, and from deep space probes millions of miles away. Every single image, from every angle, from every space agency around the world, confirms the same thing. Earth is a sphere. This direct, visual evidence, seen with our own eyes and through the lenses of our spacecraft, is the ultimate confirmation of what science has told us for centuries. Finally, let's consider modern travel and communication. When you board a plane for a long-haul flight, your pilot doesn't chart a course on a flat map. Airlines use flight paths based on a spherical Earth model to find the shortest, most fuel-efficient routes, which are often great circles that appear as curves on a flat map. Similarly, the Global Positioning System, or GPS, that you use on your phone every day relies on a network of satellites orbiting a spherical Earth. The calculations for your precise location involve complex geometry and relativity that would be completely nonsensical if the Earth were flat. The system works with incredible accuracy because its fundamental assumption that it's orbiting a globe is correct. Every time you fly or use your phone for directions, you are using technology that proves we live on a sphere. So, from watching ships sink below the horizon, to gazing at different stars, to the very existence of time zones and the constant pull of gravity, the evidence is all around us. When we add in the irrefutable proof of lunar eclipses, photos from space, and the technology that powers our modern world, the conclusion is inescapable. The idea of a flat Earth is a fascinating thought experiment, but it doesn't hold up to the reality we can observe, measure, and experience every single day. Our world is a dynamic, beautiful sphere, a home that continues to reveal its wonders to those who are willing to look. Thank you so much for joining me on this scientific journey today. Exploring these big questions is what makes learning so exciting. If you enjoyed this video and want to dive into more fascinating topics, please hit that like button. And do not forget to subscribe to the channel and turn on notifications so you would not miss our next adventure. We'll see you in the next video.